At this point, the container has its greatest potential energy. Once it's released, that potential energy begins to become kinetic energy. Also, once released, the parachute adds air resistance to the container, slowing its velocity.
During the fall, the container accelerates, but slower than negative 9.8 meters per second squared because of the air resistance from the parachute.
When the container hits the ground, the water balloons compress enough that they explode, but the animal cracker bucket only compresses a little since it's sturdy plastic. The egg suspended within the tights in the container follows inertia downwards and nearly hits the side or bottom. But instead, the inertia is slowed by the paper shred, the impact is avoided, the velocity is slowed down, and the egg suspended in the tights bounces up and down in the container, the bounce getting smaller each time until it is still and in one piece. Hi, I'm Andi Christopher, and I'm here with my lab partner, Micaela to discuss our egg drop project, in which we created a container to protect an egg so that when it's dropped from 100 feet, the egg will survive. This whole process was based off a scientific method. So Micaela, will you please explain to the audience what we did first?
Well, first, just like the scientific method, we researched it to see what other physicists would do in a similar situation.
Cool! Then what did we do?
Well, then we created a hypothesis, two actually, and then we created a model so that we were able to test the hypothesis.
Did those models work?
Well, when we tested them, both the eggs broke, so no, they didn't.
Darn. So since they didn't work, what did we do next?
Well, we revised our hypothesis just like the scientific method, and we created a new model, which we then tested again.
Where did you test those?
We tested it off Kusel Stadium, and then at the parking garage of the mall, which is about 50 feet. And it worked off the 50 feet, so we figured it would work off the 100 feet real thing. And so, by testing it a bunch of times like this, that's just like the scientific method.
Did it work in the real project?
It did!
I'm so glad it worked. Thank you for talking to us today, Micaela.
Of course. The first part we added was the container. We chose the animal cracker container because it was made out of hard plastic, which was not likely to bend or dent during the fall. It also had a voluminous belly for the egg to sit in.
We used the tights as suspension because they would form around the egg, not harming it, and when tied tight would keep the egg from hitting the container on the sides or the bottom. This helped keep the egg alive at the high velocity it was approaching the pavement with.
The paper shred is stiff enough to keep the egg from hitting the side when it is surrounded by it, but also compressible enough to not break the egg. Even though the egg is suspended and not likely to hit the side, the shred confirms this by slowing down the velocity on impact.
We use the water balloons to assist in slowing down the velocity of the container on impact. The water balloons help to spread out the force caused by the impact with the pavement, keeping the force from going to the egg. The water balloons also were used as a weight to get our container to 1 kilogram.
The parachute we took from a model rocket was used to create air resistance during the fall and slow down the container. It was also supposed to keep the container upright, but this only succeeded for about half the fall.